This is Algebra 1, Lesson 2.3, Subtraction of Real Numbers. Basically just combines with uh, yesterday's lesson, addition of real numbers. We subtracted them using a subtraction rule. All the subtraction rule is, we'll get to it in a second, is you just make addition out of it. A lot of y'all learned in previous classes, you learned keep, change, and change, keep, change, and all of that. All that'll start kind of making sense when we start talking about the subtraction rule. What are terms? Now, terms, we'll talk about what terms are, and everybody kind of understands what they are, but sometimes they try to make things that aren't terms into them. What separates terms are addition and subtraction. So when you're looking at a problem or when you're looking at an expression, anything that has plus or minus in between it are terms. For example, 2 plus 3. Those are two separate terms, 2 and 3. But 2x is only one term. That's not 2 because there's no plus in between those. Even if I put 2x, y, z, even though you can clearly count 1, 2, 3, 4 things right there, it's only one term because there's no plus or minus in it. So anything that's separated by plus or minus, those are represent different terms. Here's a subtraction rule. It says to subtract b from a, add the opposite. And again, here's your keep, change, keep, change, or whatever all that stuff is. This is what it means. Add the opposite. The reason we do this is to where we can follow the same rules with addition and subtraction. So a minus b is the same thing as a plus a negative b. One of my goals this year as a teacher is to get you guys thinking of addition and subtraction as the exact same thing. Addition and subtraction are the same thing, just like minus and negative is the same thing. Addition and subtraction are just putting numbers together. It doesn't matter if it's addition or subtraction. You just go on left on a number line versus right on a number line with a negative versus a positive. But the subtraction rule, 3 minus 5 is the same thing as 3 plus a negative 5. Then you just follow the exact same rule we learned yesterday. Opposite signs, you subtract the absolute values. Keep the bigger sign. So the result is the difference. And everybody knows that subtraction is difference when you see that keyword difference. The difference of A and B. Here's example number 1. Evaluating expression says, evaluate negative 5 minus 3 minus a negative 1. And this is the reason we do add the opposite for this part of it right here. And we had one like that on the bell work that he did a minute ago. Negative 5 minus 3 minus a negative 1. Minus a negative 1 minus 5. When you add the opposites to all these, negative 5 minus 3 becomes plus a negative 3. Minus a negative 1 becomes plus a positive 1. And oftentimes I'll have students do this. I'll have them draw in. Anytime you have minus a negative, draw the two lines in and make it plus a positive. But you can see that's what happens right here. Plus 1. Minus 5 means plus a negative 5. Now it becomes just what we did yesterday. It's all addition now. Negative 5 plus negative 3, same signs. You add them up. 5 plus 3 is 8. Keep the common sign, negative 8. Then it's negative 8 plus 1. Opposite signs. Subtract them. 8 minus 1 is 7. Keep the larger sign. So you got negative 7 plus negative 5. Same signs. Add them up. 7 plus 5 is 12. Keep the common sign, negative 12. So same signs, add them, keep the sign. Opposite signs, subtract them, keep the bigger sign. Here is another one that's just like that one for the back, everybody. Copy that one down. Find the difference. Do what we just did. Add the opposite. Take about 30 seconds. Yep. Negative 6 minus 3, if anybody's having issues seeing it. Negative 6 minus 3. So we had negative 6. We're making it plus a negative 3. And we're treating it just like yesterday. Now it's addition. Same sign. Both of them are negative. So you add 6 plus 3 and you get 9. And you keep the common sign negative 9. Try this one. 1/2 minus 2/3. Add the opposites. Now you got fractions, so I'll give y'all about a minute on this one. Make sure you got the common denominator. And then treat it like opposite signs. Oftentimes, students will get stuck on these types of problems, not because they're exceptionally difficult, but they just don't know what to do first. So what we'll do first is we'll convert both of them to have like denominators first, to where we can look at them and use the subtraction rule. The smallest number that 2 and 3 go into is 6. So 2 times 3 gives you 6. So we got to multiply the top number by 3 as well. So we get 3 over 6. 3 times 2 gives you 6. So we got to multiply that top number by 2, and we get 4. We still got minus in the middle, though. Now, using the subtraction rule tells us that we're going to take 3 over 6, and we're going to add the opposite, negative 4 over 6. Now what we got is an addition problem with opposite signs. So take the larger absolute value 4 and subtract the smaller absolute value 3. So 4 minus 3 is 1. Your bottom number 6 common denominator stays the same. And you keep the larger absolute value sign. You keep negative, and it's negative 1/6. This one's a little bit easier. Do this one. Take about 30 seconds. Remember to add the opposite. So we got negative 15 minus a negative 6. Subtraction rule says we want to add the opposite, negative 15, plus a positive 6. So now we got opposite signs. One's negative and one's positive, so you subtract the absolute values. 15 minus 6 is 9, and you keep the one that has the larger absolute value, negative 9 for that one. Okay, example number 2 is finding terms. This is easy. If it's separated by addition or subtraction, it's a separate term. If they all have negatives and stuff, the negative that's in front of whatever you're talking about goes with it. So if you just look at what's up here, negative 3 minus 8x minus y. This is one term, negative 3. This is another term, negative 8x. This is another term, negative y. And you can see that's what's written right there. It says rewrite the difference as a sum. That's just using the subtraction rule. Negative 3 plus a negative 8x plus a negative y. Notice that's exactly just what I circled up there at the top. Negative 3 minus 8x and minus y. Those are the three terms. Again, if two things are next to each other, if they multiply, they are not separate terms. So this should be very, very simple for you to understand. Let's see how well you do on the back. What are the terms of this problem? Very simple. Take about 15 seconds. Okay, we got 3x minus 5. If you rewrote it using the subtraction rule, you would say 3x plus a negative 5. That's not necessary, really, because you can see that this is one term, 3x. This is the other term, negative 5. However, if you did write it as a subtraction rule, you can see 3x and you can see negative 5. So those are the two terms. 3 and x are not separate terms because they are not separated by addition and subtraction. So here we go. Evaluate these. 1 minus 2 minus a negative 3. 1 plus a negative 2, again, that's the subtraction rule, minus a negative 3. Add the opposite, plus 3. So 1 plus a negative 2, opposite signs, you subtract those two. 2 minus 1, and you get 1. And you keep the larger signs, the larger one's value. Negative 1 plus 3, bring this one down. Opposite signs again. Subtract them. 3 minus 1 is 2. And this one's the larger value now, so you keep the larger sign 2. Find the terms of this one. If you separate it, negative 8 plus a negative 7x. Here is one term, negative 8. Here's the other, negative 7x. Or you could have just looked at this problem and said, there's one term, there's the other. Evaluating a function, just like the bell word. X is equal to negative 2, negative 1, 0, and 1. When you plug those values in, 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. 2 times 0 is 0. 0 minus 3 is negative 3. 2 times 1 is 2. 2 minus 3 is negative 1. So those are your values. Notice each time x goes up by 1, y increases by 2. That's your constant increase. Constant increase. We're going to skip number 4 just for the sake of time and look at the checkpoint value. Y equals negative x. Same thing, same input-output machine. Using the same values, negative 2, negative 1, 0, 1, and 2. We got 5 of them to use this time. Negative 2, so it's negative x. So what it becomes is minus a negative. So you add the opposite, is positive 2. When you plug in negative 1, it's minus a negative again, so it becomes 1. 0, it doesn't matter how many times you have negative 0. There is no such thing as positive and negative 0. We talked about that a little while ago. 0. When you plug in 1, it's negative, and then the value 1. That's why it's negative 1. And when you plug in 2, it's negative, and then the value negative 2. So each time x increases by 1, y decreases. You can see it's going down by 1 every time. X increases by 1, y decreases by 1. And then we're not going to do 4 either. So that'll be it.